Alright, hello, my name is Chris Middlemiss and I'm here today to talk to you about CleanVolt, the new era of surge protection. Energy surging is a growing problem, especially with our modern electrical systems today. There are actually three main types of surges that we're going to discuss. The first one, lightning events. The next one, utility events. And the third one we're going to focus a little bit more on today, and that's internally generated surges. Not a lot of people are aware of internally generated surges and what they are, so we're going to discuss that one in detail. But first, let's watch a few videos. This is an example of a lightning event. Lightning events happen very quick. There's a lot of energy at once, but they are pretty rare. Not a lot of people do get hit by lightning, and in fact, when a lightning event happens, 80% of the time, the lightning strike isn't direct, it hits a power line and it enters the facility through that transmission cables. Utility events. In this video, what you're going to see, there's a minivan here that's hit a power pole, and you're going to see some utility surging. So if you're connected to this electrical grid right here, your system would be getting pounded with electrical surges. Utility events can happen many different ways. Line slap, that's when the wind can blow some lines together. Animals, we hear stories of geese when they're migrating, they'll run into lines. Cats and transformers, squirrels, things along those lines. And then accidents, like in this video here. So again, utility events are rare, but they're more common than lightning events, and we find that with today's modern grid, they're becoming more and more common. The third type of internally generated surges, and in my opinion, they create dirty power. What most people don't realize is that at a power panel, all of our electricity is shared by all of the connected equipment, and therefore it all interacts with one another. A good example of this, I like to tell the story of when I was a kid. I'd be watching my Saturday morning cartoons, and my mom would be in the kitchen with one of those hand blenders to make the pancake batter, and she'd turn it on and the TV would go all staticky. That's an example of the interaction in our electrical systems. Or perhaps you've seen it when you start your dryer at home and the lights dim quickly. What happens there is there's a quick little voltage drop, a pressure drop in the system, and those pressure drops are always followed by a surge of current. Just like if you were kinking a hose and trying to drink out of it, somebody's kinking it, you're going to get pressure drops, and when it unkinks, it's going to blast water out. See a quick example of how damaging that could be? So according to university studies, these moderate surges are happening constantly in our facilities. In offices, about 9,000 times per hour we can have these surge dynamics, and in major manufacturing facilities, up to 500,000 surges per hour can happen. And this damage is slowly degrading our electrical equipment. So, what does dirty power look like? I often talk about dirty power, and people say, well, I don't understand exactly what dirty power is. Dirty power is basically, transients and surges that are in the electrical system that shouldn't be there. So here's a quick video of a gentleman who has a solar inverter, and he's showing his electrical system with the inverter off to show the cleanliness of the power, and then the inverter kicks on, and what you're going to see is all of this red here, and that's the transient levels, is going to explode.
I just turned the inverter back on, the solar inverter, and it takes a couple minutes to ramp back up. But as you can see, we have about 300 to 800 to 800 on the dirty electricity Stutzer meter. Okay, so the inverter just kicked back in. So what we're finding is the inverter creates dirty electricity, but so do all the other homes in the neighborhood.
It's very interesting what he says at the end of the video here, and so do all the other homes in the neighborhood. Just like how within our own home, all of our connected equipment shares the same power and therefore interacts with one another, When we're on a grid, we actually share the same power as our neighbors. So if we have a neighbor downline from us who's doing some stuff to create dirty power using saws, welding machines, things along those lines, we are going to be susceptible to the dirty power that is created by our neighbors as well. So again, the problem is getting worse and worse every single day. Common causes of dirty power. The number one cause of dirty power is nonlinear loads that manipulate the 60 Hz AC signal. Some examples of that are light dimmer switches, LED lighting, lap computers and laptops, printers and scanners, TVs, VFDs, multi-speed fans, battery charging devices for our phones or tablets, our electric vehicles now, high efficiency motors, renewable power systems like wind and solar. These electronics have switching power supplies, and the problem is getting worse every day. I mean, think about it. Have you gone lately and replaced all of the lights in your house with LED? If you have, you've just added a whole bunch of switching power supplies that create dirty power to your electrical system. So the science behind CleanVolt and its effectiveness comes in these three white papers here. In 1977, there was a theory introduced that energy surging on the current waveform was creating inefficiencies in electrical systems by creating heat and resistance. In 1984, another electrical engineer set out to test and disprove that theory, but what he found out was it was actually true, that energy surging is creating inefficiencies within our electrical system due to the resistance and the heat that is built up as the cause of the energy surging. And then last year, NEMA came out with a white paper, and what they did is they took a whole bunch of different electronics, a bunch of different types of light bulbs, a VFD, a UPS, and they subjected all of these electronics to moderate surges that would be found in the regular voltage that they're designed to operate within. Long story short, they were able to destroy every piece of electronics by hitting it multiple times with moderate surges. So again, the enemy to our electronics these days isn't the big catastrophic events, the lightning events and the utility events. It is the internally generated moderate surges that are being created within our own electrical systems by our electronics. This is a sine wave here. A typical 120 volt system has a sine wave peak of 169 volt peak to peak. 80% of the surge dynamics that happen in our electrical systems happen within this peak to peak waveform. But if you look at traditional surge protection on the market today, they all use metal oxide varistors, and the challenge with that technology is it reacts way too high to do anything about this moderate surging. The lowest clamping we've seen in the industry from a metal oxide varistor device is 330 volt clamping or reaction time, with the average being about 500 to 600 volt clamping and reaction time. So how can we have an effect on the moderate surging if the technology doesn't react until at least 600 volts? Well, we said this doesn't make any sense. If our electronics are designed to operate at 120 volts, and according to the manufacturer, plus or minus 10%, so up to 132 volts safely, why don't we have a technology that keeps our connected equipment within the voltage that it was designed to operate within safely to extend the life of the equipment and actually be able to get the lifespan out of it that the manufacturer designed. So that's what we did, is we said, let's build a varistor technology that can actually participate within the fundamental waveform, clamp at 132 volts, keep our connected equipment within the voltage tolerance it was designed to operate within, and therefore remove 80% of the surge dynamics that are happening in our system and clean up all of that dirty power that's created from the interaction. The concept of a surge protection device obviously is to protect your system from surges. When it comes to major surges, lightning and utility events, although they're rare, they do have a significant amount of energy that may enter your system. Main breakers, overcurrent devices, they react too slowly to do anything about the surge. A main overcurrent device is designed to take your system offline in the event of a utility event. They just don't react fast enough to do so without damage. And moderate surges, our connected equipment, while performing normal functions, create energy surging within the peak-to-peak waveform, resulting in interaction between connected devices. I like to refer to this as death by 1,000 cuts, the electrical version. It's not a Mike Tyson punch-out surge that's coming in to take out our electronics. It's just little jabs that happen every day, every second of every day, that slowly degrade our electronics to the point where they fail prematurely. The current problem with metal oxide varistors when it comes to major surges is they have not proven to have the ability to buy your overcurrent device the valuable fractions of time required to disconnect and take that system offline. And moderate surges, MOVs generally react at twice peak voltage, therefore having no effect on the surge dynamics happening within the actual peak-to-peak waveform. The CleanVolt difference. CleanVolt's been in the industry now for 19 years. We were designed and certified originally as a lightning strike surge arrestor, which means we had to pass a lot more difficult testing and withstand a lot larger surges than a traditional surge protection device today that is part of the 1449 category for UL. We also have the highest instantaneous Ka rating in the industry, which means our technology can absorb the most amount of energy instantaneously in the industry. Fastest connected reaction time in the industry, again verified by third-party labs, UL and ANSI. When it comes to major surges, CleanVolt has the ability and the robust nature to attract catastrophic events, buying your main breaker the valuable fractions of a second needed to properly turn off with limited cascading damage. In the event of a catastrophic surge, CleanVolt becomes the path of least resistance for that surge and will hold it back for long enough that the main overcurrent breaker will trip. Again, no other surge protection device on the market has ever been known to trip a main overcurrent breaker in the event of a catastrophic surge. And with moderate surges, CleanVolt's varistor actually participates within the fundamental waveform, removing damaging moderate surges that are caused by the interaction of our equipment. The benefit, every second of every day, CleanVolt is cleaning dirty power from your system while also providing the best catastrophic protection available on the market. So obviously we can't see electricity, and for 19 years we've been getting great testimonials and great feedback from our customers. Everything from I'm saving money on my bill, my power factor is increased, my system runs cooler, lots of these things. So what we decided to do is go out and invest in a Dranitz power quality analyzer and start to actually look at systems before CleanVolt was installed and then after CleanVolt was installed. Here's an example from one of our customers. This is the waveform. This is a 120, 208, three-phase system. Not one of those phases is running at 120. One's running at about 150, one's running at about 130, and the other one's running at 90. And we also have 30 volts on the neutral. So the first thing that we saw was that there's an actual mechanical issue with this system. Something to do with the grounding and bonding. Phase C is bleeding 30 volts over to the neutral. Because of that mechanical issue, take a look at that waveform. That should be 169 volt peak to peak. One of those waveforms is over 200 volts. And as you can see, there's no symmetry, it's a complete mess. After CleanVolt was installed, without addressing the mechanical issue, we were able to get that waveform now to 169 volt peak to peak, all three phases running at 120, and we've taken the 30 volts off the neutral as well. When it came to power factor in this system, the third from the bottom, the scale before was from 0 to 0.5. The scale after is 0.25 to 0.75. So CleanVolt was able to naturally correct the power factor issues in the system by 25 points. And then harmonics are becoming a big issue with our modern systems today. Before, there was about 14 volts of total harmonic distortion on the voltage waveform, and afterwards we have that number down to 3.86. A 72% reduction in total harmonic distortion. That's pretty significant for a passive surge protection device, and that's the difference between participating within the fundamental waveform versus just being a spectator waiting at twice peak voltage for a surge event to happen. We also do thermal imaging. This is from one of our customers. This is from a chicken barn running exhaust fans under extreme heating conditions for about 8 years. As you can see before, there's a lot of red, there's a lot of white. Those breakers are quite hot. Our customer installed the CleanVolt unit on the bottom right-hand breaker, and what's very interesting, if you follow these pictures, is you can actually see the heat moving from the breakers that are up top, down the bus, and being attracted to the CleanVolt breaker, and being dissipated as heat, and then ultimately being cooled to the touch 156 hours after. And again, the reason is because CleanVolt is now the path of least resistance for all the transients and all the dirty power that does not belong in this electrical system. It's absorbed to the CleanVolt, dissipated as heat, and removed from the system. There's the before, and there's the after. And you might notice, yes, there is still some very hot spots at the top, and the reason for that is this panel was under extreme heating conditions for 8 years. We know that that bus has some micro arcing happening, and CleanVolt cannot reverse damages. So again, we get testimonials roll into our head office at least one a week. We hear some great stories from our customers about them saving money, or perhaps they were hit with lightning and the CleanVolt unit protected their system and they're calling in to warranty the unit. And you can visit our website and go and read more about our testimonials. Not only that, but you're probably thinking you have a lot of questions right now. I highly recommend go and visit our website, www.cleanvolt.com. Our frequently asked questions section will address all the questions you have about harmonics, power factor, savings, anything that you're thinking right now is probably going to be addressed on the website in the frequently asked questions section. If not, feel free to send us an email and we'll get your questions answered. Thank you very much for spending time with me today.